Hello everyone, how are you? And in this video we're going to extend the information we saw in the previous two videos on straight line graphs. We've looked at the basics of what straight line graphs are, what their gradients are, but now we're going to look at some natural extensions of these ideas. Some of these might be obvious to you, in which case, well done. Others maybe not, but either way, I hope this video gives you a better understanding of straight line graphs. The first extension is the gradient equation. If you know the coordinates of 2 points on a line, then you can calculate the gradient of that line using this equation. If the 2 points are x1, y1 and x2, y2, then m, the gradient, is y2 minus y1 all over x2 minus x1. And just before we move on, note that these are subscripts, y2 and y1. These are identifiers for different points. Superscripts, like x squared, are powers, and the difference is very important, so make sure you don't get that confused. However, if we subtract one y coordinate from the other and divide that by the subtraction of one x coordinate from the other, that will give us the gradient, and it will always give us the correct gradient as long as you keep point 1 and point 2 correctly paired. Try it now. What is the gradient of a line that goes through the 2 points 211 and 419? And we'll do this example on the next slide. So here are the 2 points that we plotted. Let 211 be point number 1 and 419 be point number 2. And then if we plug those numbers into the equation, 19 minus 11 over 4 minus 2 is 8 over 2, and 8 divided by 2 is 4. So just before we move on, what exactly are you doing when you use this equation? What do you think this equation is doing? I'll tell you now. What this equation is doing is calculating the rise over the run, but just doing it more abstractly. It's never turning it into a triangle or even thinking about it as rise over run. We've just got a formula which calculates the numbers. But there is the triangle, and you can see if we go up in the x direction by 2, then the graph goes up in the y direction by 8, giving a gradient of 4. But what if we swap the points over? What's going to happen if we let 419 be point 1? Well, we get exactly the same result, but the difference is the numbers will be negative. Minus 8 divided by minus 2 is still positive 4, which is the correct gradient. So now that we know the gradient, we can work out the equation of the line. We know that when x goes down by 1, y goes down by 4, and so we can work out that the line will go through the point 1, 7 and then 0, 3. This means that the y-intercept is 3, so the equation of the line is y equals 4x plus 3. And we've worked out the equation of this straight line by knowing the coordinates of just 2 points on that line. It's worth noting that for any 2 points in space, they will always both be on one and only one straight line. Choose 2 points and there will be a straight line that they will both fall on. But equally, there will only be one straight line that they both fall on. This might seem a little strange to think about at first, but if you think about it carefully, if you move either one of those points, then either you are making a new straight line, or the line that goes through both those points is no longer a straight line. It is now a curved line somehow. Our second extension to straight line formulas is simply to say that all values of x will work. These straight lines don't just work for whole values of x and y like we have used so far. all numbers will work. For example, we could let x be equal to 1/2 in our line y equals 2x plus 1. If we plug in x equals 1/2, then y is 2 times 1/2, which is 1, plus 1, which is 2. And you can see that point falls on our straight line. If x is minus 1/2, then 2 times minus 1/2 is minus 1, plus 1 equals 0, which falls on our straight line. And if x were to be 1/2, 2 times 1/2 is 3, plus 1 equals 4, which again falls on our straight line. I've used halves here to keep it simple, but you can plug in any value of x you like. 1/4, 4/8, 3/16, 0.597, and any value of x you plug in, if you work it correctly through the formula, will give you a point on the y-axis that falls on the straight line. Our next extension is kind of the opposite of that. It's not just x and y values that can be any number. The m and c values, the gradient and the y-intercept, can also have any value. Here we have a strange looking straight line equation. Y equals minus 1/2 x minus 1/4. We can already see from minus 1/4 that the y-intercept will be at that point, y equals minus 1/4. And now let's plug in some other values of x into this equation. If x equals minus 3, then minus 1/2 times minus 3 is positive 1/2. But then subtract 1/4 and that gives 1/4. If x is minus 2, minus 1/2 times minus 2 is positive 1, minus another 1/4 gives us 3/4. And similarly, if x is minus 1, minus 1/2 times minus 1 is positive 1/2, but positive 1/2 minus 1/4 is just 1/4. And we see the reverse on the other side. If x is 1, then minus 1/2 times 1 is minus 1/2. And then minus another 1/4 gives us minus 3/4. If x equals 2, minus 1/2 times 2 is minus 1, and subtract the 1/4, we're at minus 1/4. And finally, if x equals 3, minus 1/2 times 3 is minus 1/2, and minus 1/2 minus 1/4 is minus 1 3/4. So even if m and c are not whole numbers, the straight line equations still work. And on top of that, you can still work out the gradient in exactly the same way. Here, if we go along the x-axis by 4, then we go down in the y-axis by 2. So that's minus 2 divided by 4, which gives us the gradient of minus 1/2. And once again, I've chosen fairly simple values like halves and quarters here, simply so that you can see this working. But any value at all that you put into the gradient or the y-intercept will give you a completely new straight line. And our final extension, which is perhaps the most complex one, is that lines can cross over. And that might seem obvious, but we can also learn quite a lot from this fact. Let's take both of our simple examples and put them onto one graph. So here are both the lines we've used in earlier videos, y equals 2x plus 1 and y equals 3x minus 4. And you can see immediately that these lines are not parallel and that they meet at a certain point. It's just outside the graph space, so you might be able to work out that point just by looking at it. Have a try at that now. But in actual fact, you don't need to work it out by looking. There is something else you can do. Because the two lines meet at this point, the two equations are therefore the same at this point. And if you don't know, whenever anything is the same in maths, that means we can put it around an equals sign. We can therefore solve for this point from the equation 3x minus 4 equals 2x plus 1. Let's rearrange that first. 3x equals 2x plus 1 plus 4. That's plus 5. Let's move the x's over to the other side. 3x minus 2x equals 5, which means that x equals 5. So these 2 points meet. So these two lines meet at the point x equals 5. And we can now use either one of the equations to confirm that when x equals 5, y will equal 11. Therefore, these two lines meet at the point 5, 11. So let's finish off with a challenge question or two. You can now use algebra to calculate where our first two simple lines will meet with our more complex line y equals minus a half x minus a quarter. So if you're not sure how to do that, go back and watch the video again before you give it a try. I'm going to go through the first one of these questions now so you can see if you have the process right. But please do try and work it out for yourself first. So we put the lines equal to each other. Y equals 2x plus 1 equals minus a half x minus a quarter. So we're now going to do a bit of algebra to move that around. We'll move the 1 first, so that becomes minus 1. We have 2x equals minus a half x minus 1 and a quarter. And now we can move the x term. It's going to become plus half x, so 2.5x equals minus 1 and a quarter. Now this is where it gets a little bit complicated where fractions are concerned. We're now going to move 2.5 over to the other side by dividing both sides by 2.5. We now have x equals minus 1.25 divided by 2.5. Now this is quite hard to work out in its current form, but we can rewrite it as x equals minus 5 quarters divided by 5 halves. And if you're familiar with dividing and multiplying fractions, you can quickly work out that that will come out to minus a half. We can now see that x is minus a half, and y we can work out with either equation is now going to be at the point 0. So the first two graphs meet. So y equals 2x plus 1 meets with the line y equals minus a half x minus a quarter at the point minus a half 0. Did you get that one? And can you do the second equation on your own? And that's where we'll leave our little look at straight lines and their equations, their gradients, and a few extra points. I hope that you've understood these videos and found them helpful. Remember that just watching one series of videos that goes through it in just one way will not make you good at drawing straight lines or solving their equations. You have to practice it on questions so that you can get the process into your head and it becomes natural for you. But I hope this video has helped you out, and thank you for watching.